Welcome to Brettley Built. I'm Brett, and today I'm going to be installing my Toso mini split air conditioner. This mini split does get delivered in two boxes. This is the outdoor unit. This is the indoor unit. And these are all the things that should have came with it. And there is also a list of these things in the user manual. In the user manual, it does give you a very detailed process of how to install the unit, but it doesn't tell you how to do the electrical work to actually power the unit. It does suggest that you hire an electrician to do the work for you, but in this video, I would like to explain some things to you that might help you to feel a little bit more confident about maybe doing the wiring yourself. So let's start with your service entry panel. So coming out from the pole into your house, you're going to have 220 volt hot lines, and you're going to have one ground line. The ground line is going to be generally a bare wire, and it's going to come in and attach to a lug that's going to be attached to those buses. They're actually silver on the sides and they have all the screws in them. So that's going to be connected to the buses, they're called, and they're bonded together. And so this actually is essentially one piece of metal. And the two hots come into these lugs and they connect to these bars that your breaker's attached to. And so how this works is, let's say you have a toaster, and from the toaster, your wire's gonna have a black hot wire. It's gonna have a green ground wire, and I'm using blue, but it's actually white for a neutral wire. So your neutrals connect to the ground bus. Your greens connect to a ground bus, and keep in mind, it doesn't matter which side because they're bonded together. And your hot wire connects to a breaker that you have attached to one of these pieces of metal. And so if you notice, this actually completes a circuit because the hot leaves the breaker from the 120 volts coming in, goes down to your toaster, you push the button, and now power goes through the toaster, creating heat, and comes back to your bus. And so you've just completed a circuit. So what's important about this is a 110 volt system. Even though it says 120 volts, the grid is required to power 120 volts, provide you with 120 volts each leg to your house, but usually devices are 110 or 115 volts. So they're a little bit less than what the grid provides. So what makes this a 110 volt system is a difference in voltage, 0 volts at the ground and 120 volts for your hot coming in. So there's a difference in voltage here of 120 volts. The toaster was a 110 volt device because it was only being powered by one of these legs. And so let's say we have a bigger device. Let's say we have a dryer. So with the dryer, let's say we have, and the dryer is going to be your 220 volts, 230, somewhere in there. It's going to be less than the total amount of voltage that comes into your panel. So in order for this to be a 220, 230 volt device, you're actually going to have two hot wires that come up into the box, and you're going to have a ground wire that comes into the box. So I'm sure you know where the ground wire goes by now. Goes over to the ground bus. Now this is where it gets interesting. The reason these bars are shaped this way is because you actually need the power from both legs to power this device. So you can't just hook up two breakers on the same leg and then expect to power the whole 220 volt device. So what actually happens is you have a breaker, which is called a double pole breaker, which is essentially two breakers in one. And what it does is it actually attaches to both sides of the 120 volts that come in. And so it's going to look like this and hook up on one side, but internally it's actually connecting to one side and it's connecting to the other side of these bars coming in, providing 220 volts. So this looks a little bit different because you might be thinking that the power just comes back, the hot wires come out, provide power to the device, and go back to the ground. But that's not actually what happens. So kind of an analogy for how the 120 and the 240 volt systems work is, let's say that you're out and you're, let's just say, rolling a barrel. So if this is a 120 volt system, you're the only one pushing. So you're gonna sit there and sit there and push the barrel, and you're gonna do all the work. With the 240 volt system, there's gonna be you, and there's gonna be your friend. So what you're gonna do is you're actually gonna take turns pushing the barrel. So what you're gonna do is you're gonna take a turn and push, and this barrel is gonna roll halfway, and then your friend is gonna take their turn and they're gonna push it the other way around. So now this barrel has completed one loop, but two people have pushed. We're up here with 120 volt, you're the only one doing the pushing. So whenever you purchase a device, is it a 120 volt system or 110, 115 volt system, to where you're only gonna use one black wire to go into one breaker, which is just has the one switch on it? Or are you in the situation where you're gonna have two hot wires that are both gonna be doing the work? And what you have in that instance, you call a double pole breaker. So what this breaker does is it actually connects to both legs, so it's providing 120 volts from each leg. And this double pole breaker is actually going to be connected together, so you flip it on or flip it off together. So I'm going to put a link in the description, but there's a technical specification sheet that you can look at for whenever you buy one of these devices, and this might actually help you determine what type of device do you want to buy. Do you want to buy a 220 volt device, or do you want to buy just a regular 110 device? So the data on the technical specification sheet is going to be very important when you buy the unit and when you're getting ready to hook it up. So as I'm looking at the technical data sheet, so for the power supply, you'll see that it says 60 hertz and one phase. Don't really pay attention to those because all the power in the United States is 60 hertz, and generally your house is going to be single phase, so don't worry about that. What you want to pay attention to is the voltage. On the first unit, it has 115 volts. And so if I have 115 volts, based on what we just saw from the panel box analogy, with the two legs coming in 120 volts apiece, you know you're only going to need the single breaker. But if you go to the next unit, it says 208 to 230 volts. So you know to provide that much voltage, you're going to need a double pole breaker. So this says single pole breaker. This is going to be the double pole bonded breaker that turns on and off, that powers two hot lines. So on the sheet there's 5 units, and you'll see that there's different voltages for each unit. They might be the 115 or they might be the 208 to 230. So whatever unit you get, you need to make sure that you buy the proper breaker. So just so everybody's clear on the max overcurrent protection, meaning the largest breaker that you want to put in the panel box to power your mini split, on the technical specification sheet from left to right, you'll see that the first unit is a 115 volt unit. Max overcurrent protection is 20 amps. So you'll know that you'll need a single pole 20 amp breaker for that unit. The second unit is a 208 to 230 volt unit. So you know it's going to be a double pole, and you'll see max overcurrent protection is 15 amps. So that'll take a double pole 15 amp breaker. The third unit over is 115 volts. So you know it's single pole. That takes a 30 amp breaker. The fourth unit over is a 208 to 230 volt unit. So you know it's going to be a double pole breaker, and its max overcurrent protection is 15 amps. So you know that's a double pole 15 amp breaker. And the last unit, 208 to 230 volt unit, so double pole and 20 amp overload protection, overcurrent protection. And so that's going to be a double pole 20 amp breaker for that unit. So the one thing that isn't on the technical specification sheet, but that you can figure out yourself, is what size of wire to use with what size of breaker. So with a 15 amp breaker, you're going to use 14 gauge wire. 20 amp breaker is going to be 12 gauge wire. And a 30 amp breaker is going to use 10 gauge wire. So I recommend using this Romex, essentially 3 wires in a jacket. Has your black wire, your neutral, and your ground wire. So you'll run this to your device, and it'll complete the circuit as the black wire will be connected to your breaker, will go out to your device, and then the ground and the neutral will come back to the panel box, connect to the bus bars. The white jacketed Romex is your 14 gauge wire. The yellow jacketed wire is your 12 gauge wire. And unfortunately I don't have any, but the orange jacketed wire is the 30 amp wire. So it's maybe a little bit of an odd convention, but the way that this Romex is described is by the gauge, so 14, 12, or 10, and it's described as a 2 wire. And even though there's 3 wires, the reason it's considered a 2 wire is you have the black and the neutral, which are actually conducting the current, and then your ground is just there as a safety. So you just got your mini split, and you have your panel box, and you have a 115 volt system. So you know it's going to be a single pole breaker. So you're going to have 1 black wire that comes over your mini split. You know you're going to have 1 neutral that comes from a bus bar over to your mini split. And you know you're going to have a ground wire that comes from a bus bar over to your mini split. And you remember how the circuit works. The current comes out of the hot wire, out of the breaker, comes over your mini split, powers the mini split. Current goes back through, over to your bus, through the neutral wire, and your ground's there just as a safety. So you're still going to use, and let's just say this was a 15 amp circuit. So you know you're going to use the white Romex to wire up the mini split. So specifically the unit that I got was the 208, 230 volt unit that's 15 amp max overload protection. So pretty straightforward. We have a black wire coming over to the mini split, and we have a ground wire coming over from the bus bar over to the mini split. But then where does the other black wire come from? The other black wire actually comes from the white wire in the Romex. So this might be a little bit counterintuitive because it's like, well, where's the circuit complete? But remember the analogy of you and your friend pushing the barrels? Essentially what happens is each one of you take a turn at pushing the barrel. So at a 120 volt system where you're alone by yourself pushing the barrel, the 230 volt system doesn't need a neutral. They're both hot because I'm going to push the barrel, it's going to roll halfway, and then my friend's going to come over and push the barrel the other halfway. And so you're basically just taking turns powering this device. So please don't get confused about that concept with the neutral. Every single one of these Toso units are going to use a 2 wire. So whether it's the 10-2, the 12-2, or the 14-2 wire, they're all going to use the 2 wire. It might be this configuration if it's 230 volt, 208, 230 volt, or it might be the other way where the neutral is actually hooked up to the bus bar if it's 110 volt. So the unit that I have requires a double pole 15 amp breaker, so I can use the white 14-2 Romex, but I'm actually going to be running this 12-2 20 amp wire, and the reason is if I ever want to upgrade a unit in the future, I'll have the wire in place to upgrade to a 20 amp circuit. And so I won't be overloading the wires. I'll make sure that I already kind of have the infrastructure in place to upgrade in the future if I want. So if an electrician was going to wire this up at your house, these are the things that they would need to get. They would need the wire. They would need a box, a shutoff box outside, your double pole breaker, and you would need this whip that's going to go from this box over to the outside unit. Just a heads up for this whip. These connections that I got are 1/2 inch connections. So these are other tools and materials that you'll need for the installation. These spade terminals, you're going to use those when you connect the wires in the whip to the outside unit. This tool here is actually a crimper tool here at the end. I'll describe how that's used later. It also has wire strippers in here, but I like having a pair of dedicated wire strippers. and then wire cutters, and a non-contact voltage tester, a good electrical type screwdriver, voltmeter, utility knife, electrical tape, hammer, and these Romex connectors. You'll at least need one of these, of this type here, to wire in the electrical or the information cable to the outside unit. And then I choose to use these other Romex connectors going into the other boxes. You're also going to want to make sure that you have a vacuum pump. Make sure that it has enough oil in it. You need an AC manifold set. You're also going to need a 5/16 inch by 1/4 inch male flare adapter. There'll be a link to this in the description. This connects to the service port on the unit when you're getting ready to evacuate the lines. So if an electrician was going to do the install for you, they may have to run conduit along the outside of the house, or they may have to run Romex through walls, maybe open up drywall and run the wires out to get from your panel box out to that shutoff box. Luckily, I have it pretty easy where my building is not finished yet. And so I'm gonna be able to run from this panel box. It's actually a sub panel, but I'm gonna be able to run from this panel box out through this open framing and over to the shutoff where I mount this on the wall. So I want to start by getting this box mounted. Just like in your panel box, there's knockouts that I'll be knocking out to run some conduit through the wall. The reason is this box is too tall to go between these ridges, so it's actually going to sit on the ridges outside. And I'm going to have a piece of conduit that comes in that I'll run the Romex through out to the box. I'm going to knock out this 1/2 inch knockout because this is where the wire is going to go from this box out to the compressor outside. And I'm going to knock out this knockout because this is where the conduit's actually going to go through the wall. So I'm going to be running this plastic conduit through the wall. It's going to have a coupler on it that'll fit through the knockout here, and it'll get fastened down. This conduit is UV resistant, this plastic conduit. You put it together with this medium gray PVC cement. You don't want this pooling up, just get just enough on it to get it coated pretty well. Coat both fittings. Push them together and give it about a 1/4 turn and hold it together until it holds tight. Now, depending on your situation, this part may get very involved where you're going to run a wire from your panel box over to where you're going to leave the wall out to your disconnect outside. I'm just going to come up that framing up above the door and then kind of come back where I have a cavity here. You might actually have to cut out drywall or run conduit on the outside. I'm going to be using a 5/8 spade drill bit to drill through these studs. Make sure whatever spade bit or drill bit you're going to use, it isn't too big because you don't want to take away too much material out of your joists or your studs. Whenever you're doing this type of work, make sure that your wire lays pretty flat. It'll go a long way if you have to have this inspected. Just when everything looks clean and neat, it'll look like you actually know what you're doing. You definitely want to make sure that you leave enough wire outside. I usually only leave about 1 foot because I'm the one that pays for the wire, and the wire is pretty expensive. So what I'm going to do is I'm going to make a mark with a Sharpie, and I'll push it that far through. And this is convenient if you're working by yourself, so you know you have enough wire out there. And then get this secured pretty close to where it comes in the wall. And you're going to want to staple the wire about every 16 inches. The wire should be stapled snugly, but don't hammer too hard down on the staple to where you damage that jacket. So I definitely don't want to be short with my wire coming over to the panel box here. So I'm going to overestimate by about 10 feet. So I have the power turned off to my building. This, like I said, this is a sub panel. So if you're gonna put this in your house, obviously you'd have your main panel. And your main panel is gonna have a big shut off up here or down here. It'll be like your 100, it'll be either a 100, a 150, or a 200 amp, most likely, main breaker that you'll flip off. So go ahead and take the cover off. So after removing the cover, the first thing you want to do is get a non-contact voltage tester. And what I do is I go test them with something that I know is hot. So right next door I have a building, I went and plugged it into an outlet, made sure it was working. So now I can come over and start touching everything here and make sure that there's no power anywhere. This is where the power comes in, so obviously I'm going to test here, but you know, just kind of move it around a little bit. They're pretty sensitive, so they'll tell you if there's any power in the box. So there's a few different types of Romex holders that you can put in the box. These work really well and they're really easy to install. This is what I usually use. So I don't have the time to go through it in this video, but if you look at my other video when I installed this panel, you'll see that the neutrals and the grounds had to be separated here. In your main panel, that's not the case. But on a sub panel, you have to have your grounds and neutral separated, so this ground wire is going to end up on this bus bar over on this far side. Once again, make sure you see copper come out the other end. Okay, tighten it down. Make sure that it's made a tight connection. One other thing to note about wire, copper wire, is it work hardens. So the more that you sit there and bend it back and forth, the more brittle it gets. So you don't want to be constantly in here digging around, pushing everything back and forth, moving everything. You're going to try to keep it as still as possible. So just to reinforce this concept, this is a double pole breaker. What that means is it's essentially two breakers in one. A lot of these are just single breakers. But these two breakers are actually bonded together. So when you flip one, the other one goes off. Or when you turn one on, the other one turns on. So this is important to power your device. Make sure that you have these that are bonded. This is a 15 amp. I don't know well you can see that. Light isn't adjusted very well. So that means each leg is feeding 15 amps. And remember, I have to use a 15 amp breaker because that's what my max overload protection required. Is the largest breaker I could use is 15 amps. Here are the two hot lugs that come in. So this is what I drawn on my drawing. They were up top. But you see how these bars come down, and there's these little bars that come in off from the main bar. So what each one of those do is they provide power to these breakers that are attached to these. What this double pole breaker is going to do is it's actually going to catch this leg, and then this metal here is actually coming off from this other leg, or off from this other piece of metal here that's hot. And so what that does is it provides 120 volts from one side and 120 volts from the other. That's what makes your 240 volt circuit. So there's screws. There's screws that are going to hold the wire here, and there's little tabs that hook into the back, and then there's these metal tabs that'll grab down on these brackets here or on these bars here. So then you just hook the back and you just push down. I should have made sure that was off. That's something else as well. Obviously I know the panel box is off, but whenever you go to install these, make sure that these are off. And then like I said, I usually loosen up the screws so it just makes it easier to install. And this seems like it's in place here. So to install these wires, give yourself a little bit of extra room again. Kind of bend it around and give yourself a straight spot on the wire. Strip them off about 3/4 of an inch, half an inch, 3/4 of an inch. You don't want a lot of copper sticking out the back. Okay, I'm going to tuck the wire in the back. And you want to get these snug, but you don't want to break anything. This is a lot of plastic in here. Okay, it's pretty tight. Same thing with the next leg. Okay, wire's pretty tight. So we're not quite done yet. There's one last thing we have to do. So we have all these other white neutrals in here, but then we have one white hot. So what's required is you have to wrap electrical tape or something to make this wire black, to make sure that somebody that opens up this panel knows that this is black. You don't have to do anything with the whole wire, but you do need to put some electrical tape or something on here that's black. So we have the tape on here. So, you know, it's a hot wire. I probably used a little bit more tape than was needed, but just to kind of drive the point home. So I have my cover back on, and I went ahead and labeled my chart so I know which breakers belong to the mini split. So now I'm gonna get started on installing the actual unit itself. So I'm gonna be following the user manual extremely closely to the best of my ability. A couple things that maybe I should have mentioned before, and I guess is a good time to bring it up. You're gonna see two sets of wires that they sent with the unit. So the one set has a black, a white, and a ground. So that looks really similar to the Romex that I just installed. So this is what they wanted to use as the power cable. I would absolutely recommend installing it the way that I did with the disconnect and run Romex to your panel box and connect it that way. So at this point, we're not gonna need this wire, but the control cables have a ground, brown wire, I guess it's actually a red wire with a brown jacket, and then a white wire, black wire, and this is what we're going to be using as part of this process. So I've already taken the outside unit outside and set it on the cement pad where I'm going to be mounting it. I'm going to use a cement pad because my building is metal, and the structure doesn't really facilitate an area to hook that metal bracket that sits on the side of a building, and so I'm going to have to mount it to a cement pad. We are going to have a link in the description to a bracket system that we recommend. And I also set it out there at this point because it's supposed to be upright for 3 hours to make sure all the oil drains properly in it. So if you had it, hopefully you didn't have it leaning over or something, but just have it set in place so it can just kind of even out, level out. And then when we're ready to hook it up, it'll be ready to go. So the unit sits up like this on the wall. And there's ports on this side that if you need to remove them to run the lines out, you can. I'm not going to need those because I'm going to go straight out the back. They recommend, or I guess require, that there's at least 6 inches of distance from each side and at least 6 inches to the top. This is where your filter's at. And they want 98.5 inches from the floor up to the very bottom. That seems to me like the one requirement that probably the hardest to meet is the floor to the bottom of the unit. So starting with the bracket on the back, and there's a screw here in the middle that you'll remove to go ahead and mount this on the wall. It's right here. But if you leave this bracket here and you start out your 6 inches, and I know the first stud that I have is 11 1/4. So 11 1/4 in the wall, obviously it's not going to give me the required 6 inches. But if I come out 27 1/4, then that'll let me hit my first stud. This will be my next stud, and then obviously I'll have 6 inches here, so I'll be in good shape there. I'm gonna have the lines come out the back in this corner, so I also want to measure here. So off from the edge of this bracket, so when I'm out the edge of this bracket, I'm gonna come off about 4.5 inches and maybe up 3 inches, put a hole here in the wall, and then that'll allow me to cover up all the lines here. The hole won't come out over the edge here, and I'll be able to push all my lines out the wall straight out of the back. So in section 3, connect the wiring of the indoor unit. It gives you this notice to have an HVAC or an electrician do the wiring. This is why I went through all the painstaking process at the beginning of this video, is to help you understand how to do all this wiring yourself. So for this, it says use a screwdriver. I wouldn't. It just pulls right off. There's a screw here. You take that out. And then you're gonna have your 4 terminals in here that'll connect to your 4 wires. So there's not really any way to look down in there to see where these go. So what I'm gonna do is carefully use a piece of Romex wire, fish it down around, connect these to it, fish it back through, and then I'll make all my connections. There's this little strap here that you want to make sure that you get back in place, because this is what's actually going to hold the wires in place so they don't get yanked out. Just a little clip that just goes in there and holds these down. Just looks kind of hard to fish these in. They do give you a wiring diagram. The N1 is the white, or it has the blue collar on it. The black is the 2, 3 is the red wire with the brown collar on it, and then the green goes to your ground screw. Underneath the screw there's a little metal plate. These are just going to set right underneath that metal plate. And this plastic moves quite a bit here, so be really careful. Then just make sure you get that collar back on properly. Okay, when you're all done, it should look like that. Okay, I'm going to start unrolling my refrigerant lines. I'm going to be really careful with this step, not to kink anything. So I have these line wrenches, and these are pretty handy. They're just like a box wrench, except they're just missing just a part to where it can slip over the line and move on to the nut. So when you connect these, don't try to force them. Get them just to kind of lay in there against one another, and then tighten the nut up. So we're going to get it hand tight, and then we're going to tighten it down pretty good. There are torque settings on here, but I'm going to go ahead and be really careful and just pull it tight. Same thing, don't force it, just let it kind of just lay in there. Now the power cord, your lines, and your drain line are all going to get wrapped together with this tape. So the next step is to drill a hole through all the way from the inside to the outside. And you want the hole to be about a 5 to 10 degree slope, so then as condensation builds up around the unit, it'll drain out that drain line. So I'm going to drill a 3.5 inch hole through the drywall on this side. It'll still be covered up by the unit. And then from the outside, I'm going to drill the 2.5 inch hole. There's a tolerance is like 2.2 inches to 2.8 inches that you want the outside hole to be. I'm just drilling a bigger hole on this side because I want to be able to have more clearance to bend the pipes around. Just since this is a metal building and I don't want any burrs to cut anything, I did put some electrical tape around the hole there. I'll take it off and actually put some sealant around it when I get that big line through. So I think this is kind of a two-person job. We're going to start feeding the lines through. My wife's going to be helping me. She's going to start fishing the lines through from the inside. Then she's going to come out and catch them as I finish bringing the unit up and set it into place. So if you mount the outdoor unit up off the ground, you have to use the drain plug. Mine's gonna be right down to the concrete, so I'm not gonna install the drain plug. I have the unit where I want it, so I'm gonna go ahead and mark the holes, slide it over, and drill my holes and put my anchors in. I wanna be really careful not to tip this back and forth because I've had this sitting upright, so everything is drained down to the bottom the way they want it. So I have everything ran down the wall. I'm gonna go ahead and get my lines connected up here. What you wanna do is use a pair of channel locks, or a pair of vice grips, because you don't want to really be putting a lot of torque on that fitting there. So try to hold that still. Take these caps off. Once again, just kind of let them sit on there and lightly thread the fitting on. So next what I'm going to do is evacuate these tubes. I'm going to hook up the vacuum pump to them. So since these are in a loop, it's going to pull the vacuum out of both lines. So I'll get that set up here. Okay, I'm going to go ahead and get my manifold gauges set up. Make sure everything's off. So I have my manifold hooked up. The yellow line goes to the pump. Your blue line goes over to the unit here. Remember, you need this special connection. The link will be in the description. So I follow the instructions. Turn the pump on for 15 minutes. Got it to -30. And it's been ran it for 15 minutes. Shut it off. Isolated the line with the blue valve. Now I've been waiting for a few minutes. It hasn't moved. So I'm going to wait another few minutes, and if it doesn't move, I'll go ahead and disconnect everything and put the refrigerant in it. So full disclosure, this is actually my first time using any of this equipment here, the pump or the manifold set. So kind of learning curve for me. That part, honestly, I would suggest looking at other YouTube videos and seeing how they do it. This is kind of a trial and error thing for me. Looks like it's going to work, but what I really wanted to focus on in this video was electrical work. My gauges have stayed steady, so I know that all of the air and moisture and everything has been evacuated out of the lines. So I'm going to go ahead and disconnect this and put the Freon through it. Okay, I'm going to put the cap back on. So inside here are 5mm Allen wrenches. So I have my Allen wrench. I'm going to go ahead and open these up. There just comes a point to where they stop. Let's put the caps back on. So there are two sets of screws. There's 4 screws at the top, and there's 3 screws at the bottom. So the 3 screws are going to go to your power going in, and the 4 screws up at the top are going to be your control wires, and they're going to be wired just like in the manual, just like they were at the inside unit. I use one of these connectors to connect in my control wires. So this connection is just like the whip. You'll just want to make sure that the screws are facing out towards you so they're not difficult to screw in. Okay, this is going to work for the control wires, so I'm going to go ahead and tighten up the connector here. So the wires that came with the unit have these spade terminals on them, and they just go underneath that plate there, and the screw just goes in and holds the plate down. So since I have this whip, these obviously aren't going to work to hook in here, and I wouldn't even try to do it that way. So you're going to need to buy these spade terminals, and this is actually 10 gauge wire that came with this whip. If you buy a whip without the wire, you're going to need to obviously get your own wire. I don't know if I'd get Romex as the braided wire, and this is what I'd recommend. I would just get the flex terminal, the whip with braided wire already in it. So you are going to have a pair of crimpers to make this work properly. So up here at the top, you'll see that it's color coded based on the size of wire that you're going to crimp. I have the yellow spade terminal connector, so I'm going to use the yellow slot here to crimp this down. And I didn't hook up these control wires yet because these go in front of the power wires. So I want to make sure that I get these power wires on first. Make sure there's a little bit of wire sticking through. Press down until you can't press anymore. And then pull on the connection. Make sure that it's not going to come off. There's a line 1 and a line 2 under here, and then there's your ground. We'll go ahead and hook these up. Okay, I'm going to go ahead and get the control wires hooked up. And all I'm using again is the diagram that's in the user manual. So to wire up these disconnect boxes, you're going to have your wires that are coming from the panel box. That's our 12 gauge Romex here. And there is a diagram on this little plate that goes in here to protect the wires and everything. And it has a load line. So this would be your load, this is your line. And there's another one, line load. And then here's your grounding bar. And so of course your grounds just go up to your grounding bar. Your line is always your wires coming from your panel box. So your line, you're going to take one wire up to the line side, another wire up to the line side. Doesn't matter which line goes on which side, which wire goes on which side. That's not going to, the unit doesn't care which wire's on which side. All it cares is that there's 120 volts going to each leg. So on this side is your load. That's what's going to be drawing the power. So you just take one wire up to the one lug, the one wire up to the other lug, and essentially all this is doing is just transferring power, say from the black wire up to the line, down to the black wire that's the load. And like I said, I could have easily put the red wire over here, the black wire over there, doesn't matter. What's important is that your line wires go to the line lugs and your load wires go to the load lugs. So just to stress this again, on the white wire that we're using as a hot wire, wrapped electrical tape around it, all of our wires are secure. So I'll put the cover back in place. And for now, I'm going to leave this disconnect in the off position. I'm going to go turn the power on, make sure that all of the power is correct, go into the right spot, and then once I'm ready I can turn this over and turn this disconnect on, provide power to the unit, and if anything goes wrong I'll be right here to turn it off. So I turn the power on inside. So right now what I'm going to test is the line lugs against the ground. So right there, 122 volts. The other line, 122 volts. Now, right now we should be getting no voltage across these because we haven't turned the box on yet. So at this point there's no connections being made. So everything looks good in this box, all the connections are tight. Put the cover back in place. Okay, I'm gonna go flip the switch over in the disconnect and I'll test these wires. Okay, I'm getting 122 volts from ground to the first line, and 122 volts the other line. Now, what I should get between the two lines here is 240 volts. Yep, I'm getting 244 volts. I'm going to replace the cover, and it has this weather seal, so you want to make sure you get it up tight against the unit here. I'm going to turn it on and try it out. Okay, so I don't know if you can see it, you probably can't, but now that the power's on, there's a little red button that looks just like the button on the remote, little red button for the power. So I'll hit the power, temperature comes up. And it does say that there's a delay. I have it in heat mode right now. Okay, the fan just started up. And when I went outside, the compressor is running. So right now I set the unit to cool mode. I have it set at 61 degrees here on the remote. So they do recommend that you let it run for 24 hours just to work out any kinks from the factory. And so I'm gonna keep it in cool mode for a little while and then come out and when it gets colder and turn it back and turn it into hot mode and make sure that it runs all night. It's supposed to get pretty cold tonight, so that should keep it running. So I'm kind of a stickler for how this looks, so I'm not really happy with the way my install looks right now, but I am going to put a cover over this maybe the next month or two to keep the snow off from it. And also they didn't want you to install this in direct sunlight, so that's another reason why I'm going to be putting a cover over it. The sides will be pretty open to make sure there's plenty of airflow, but there will be a top on it. And also with these coils, I'm not an HVAC technician, but they said that they don't really like these coils rolled up like that vertically like I have them. I've seen tons of people do it that way. I'm actually going to take mine and they're actually going to be more horizontal when I get my little cover built. I'm going to build a little bracket to hold those in place as well, and then I'm going to re-insulate all these lines so it'll look a lot different, a lot cleaner when I'm done. So the unit's been running more than 24 hours. We went through the initial 24-hour period, didn't have any problems, and we had it on the cool cycle for a while and it had no problems blowing cold air when it was 70-something degree day. And tonight it's pretty cool, about 38 degrees, and it's having no problems blowing warm air. Something to note about these units, they don't generate heat. What they do is they take ambient heat from the outside and pump it on the inside, and then to cool they take the ambient heat from the inside and pump it outside. So I hope this video has helped you understand how these TOSOT mini split units are installed, and hopefully it gives you a little bit more confidence and information on how to complete this process by yourself. I'm really happy with this TOSOT mini split unit so far, and I look forward to getting my garage insulated so I can have a more comfortable workshop.